Welcome to the lecture on heat sources in welding. So, now we will discuss about different type of heat sources which are used in welding process, because as we know that in welding we have a heat source which is used to increase the temperature in a localized place, and then further depending upon the type of welding process you will have the temperature distribution inside the specimen. You will have localized welding taking place or the collisions of the material taking place. So, first of all we will talk about the different heat sources, because that is also one of the way to classify the different welding processes. Why heat source in welding is important? Because in this era of energy crisis we need to also understand that which type of welding process will be giving you better efficiency, thermal efficiency. So, when we talk about the heat sources, certainly we go for the we try to go for the heat source which is readily available as well as which is cheaper, but many a times we have to choose the heat source in such a manner that you have to have the specific desired properties, like you may have to take certain heat source where the width of the heat affected zone is smaller, or time required has to be very small or so. So, you will we will encounter with different type of heat source and how their efficiency is varying, how we calculate that for that we will be having some light in this lecture. So, the different types of welding processes use different heat sources, that is very common, and the efficiency of heat sources determine the amount of heat transfer to the workpiece. So, efficiency more means the heat which is generated, more part of the heat is transferred to the workpiece to increase the temperature, so that the process of welding is facilitated. Then so efficiency of heat source will be defined as the ratio of energy transfer to workpiece and energy generated by heat source. So, if you talk about the efficiency, that is defined by eta, so it will be ratio of energy transferred to workpiece divided by energy generated by the heat source. So, depending upon the type of heat source, you can have the generation of the energy which is done by heat source, and then how much energy is transferred to workpiece, that will be calculated by the increase in the temperature of the body or so. So, if you talk about some processes like you have electro slag welding or electro beam welding. So, in those cases if you see your Q will be eta Vi. So, in those cases you have the electric current and the voltage which is supplied, and in those cases the Q which is the, so Q will be the energy transferred to workpiece. So, if you look at those processes like electro slag or electron beam welding, in those cases your supplied is generated by heat source will be Vi. So, that is your energy generated by heat source, and this is the energy which is transferred to workpiece. So, ratio of Q to Vi, that will be defined as the heat this efficiency of the heat source. Now, if you talk about one by one about the different types of welding processes. So, if you take the gas tungsten arc welding GTAW, So, as we know that in this case you have the tungsten electrodes which are used, and we certainly use some inert gases for the welding process. Now, in this case we can use the DCEN. So, that is electrode negative and work positive, because as we know that when whichever is connected to the positive terminal, your 2/3 of the heat is generated. So, this is for the direct current supply, and you may have the option of AC current also. So, in that case you will have transferring the heat for the half cycle, and in half cycle there will not be transfer of heat. So, if you take if you compare these two cases, so in that case if you measure the efficiency, heat efficiency, you will see that its efficiency will be varying from 50 to 80%. Whereas in the case of AC, you will have so for half of the cycle you don't have that heating taking place. So, the arc efficiency becomes somewhat smaller, and in this case it goes from 20% to 50%. So basically because there will be cooling in that time when there will be no heating, so that decreases the arc efficiency. If you take the example of the shielded metal arc welding, so for processes like shielded metal arc welding or submerged arc welding or gas metal arc welding, GMAW, or you have flux core arc welding. Now, in these cases we use DCEP, or you may use the AC also. Now, in these cases you have the transfer of molten metal is going on. So you will have the consumable electrodes in these cases. So, they will be heated up, and then so in this case also you will have the electrode in terms of wire. So, that will be heated up, but here it is covered under a blanket. So, so heat will be going to both the electrode as well as to the workpiece, and in that case your heat transfer efficiency will be somewhat higher. And if you see that the shielded metal arc welding, which is most of the welding processes, many welding processes are done using the shielded metal arc welding process. So, typically for the shielded metal arc welding process, typically it has been seen that the efficiency percentage is 65 to 85%. Now, if you go for the GMAW, the gas metal arc welding, that also is somewhat close to 65 to 85%. So, they are somewhat similar, this thermal efficiency or heat source efficiency is somewhat similar in these cases. Now, if you talk about the submerged arc welding, now in this submerged arc welding, as you know that in this case you will have the blanket of flux is there which is covering. So, now this difference the lower value or the value is somewhat not so high. It is because there is a loss of the heat to the surroundings also in such cases. Now, if you look at the submerged arc welding, where the flame or the arc is basically covered under the blanket of flux. So, basically that loss is minimum, and in that case the heat transfer efficiency of the heat source is maximum, and for submerged arc welding it has been reported to be more than 80 to, so it is in the range of 80 to 99%. So, that is the value of the submerged arc welding process because of the arc being under the blanket of flux, your thermal efficiency of the heat source will be more. Now, in the case of if you look at the electro slag welding. So, if you take the electro slag welding, now it is the efficiency is lower than that in submerged arc welding. Now, this is because there is so in this case you have the water cooled copper shoes which are used in the case of electro slag welding, and some part of the heat is basically lost in that. So, you will have the heat loss to water cooled copper shoes. Apart from that, you will have some loss, not very significant amount, but there will be some loss by radiation and also convection from the molten slag. So, that basically because of this the thermal the efficiency of the heat source in the case of electro slag welding will be somewhat smaller, and it is reported to be around 55 to 82%. Then if you talk about the electron beam welding process. So, this is coming again it is here you are using the electron beams to do the welding, and here you will have a phenomena of keyholing is done, and what happens that these keyholes which are formed, because you will have beams which are narrow, they will be going. So, the keyholing features basically the hole which is formed of very small diameter. Now, they actually work as the black surfaces. So, they are black bodies, and the radiation is trapped into it, and very high part of the heat energy is basically trapped into these parts. So, because of keyholing, so these efficiency becomes smaller. So, because keyholes act as black bodies, and trap the energy. So, because of that this electron beam welding process that also shows the smaller amount of so there will be some layer, otherwise it could have been even higher, but otherwise this electron beam welding goes from 80 to about 95%. So, no, in fact these keyholes which act as the black bodies and trap energy. So, in fact I was just talking in a different way. So, it's basically responsible for taking that energy more, and that leads to the higher value of the efficiency, that is 80 to 95%. Black body means it will absorb the radiation, so it will increase the temperature. There is very less amount of energy which is likely to be dispersed or to be emitted towards the environment. So, that way it will be its efficiency is quite high. Next we will talk about the laser welding. Now, as we know that in the laser welding we use the lasers, and in the case of laser welding basically the efficiency will be affected very much because of the wavelength and the energy density of the laser beam. So, here the factors which are affecting the efficiency. So, it will be say the wavelength, then you have energy density of the laser beam, you have workpiece material, and its surface condition, and joint design. So, basically on all these factors, the efficiency for the efficiency of laser welding will be depending upon, like if you have a very well polished aluminum or copper surface. So, here the surface reflectivity is high. So, for aluminum or copper which is well polished, now in these cases your reflectivity is quite high. So, because of very high reflectivity, so efficiency is very poor, because most of the energy is reflected and it does not contribute towards the heating of the material. So, in those cases your efficiency becomes very small. So, now so for certain type of materials, like you have the continuous CO2 continuous wave CO2 laser, it has been seen that it is of the order of 1%. Now, if you have the steels, if you take steel, so if you now the thing is that if you try to alter the surface characteristics so that the absorption is increased, in that case the efficiency is likely to increase. So, so if you take the steel and if you coat with thin layers of material, for enhancing absorption, in that case efficiency will be higher. So, basically if you are able to establish this keyholing feature, which is there in the case of electron beam welding, in that case you can have a satisfactory level of efficiency even in the case of the laser beam weldings. So, for laser beam welding, if you try to analyze the efficiency of the heat source, it varies from very small value to a reasonably good value, and its efficiency is ranging from maybe 0.5 to even 70%. So, if you look at, it is quite small when you have a typical type of material which has very high reflectivity, whereas if you increase the absorption coefficient, in that case your efficiency can be quite high as 70%. Now, if you talk about the other welding processes, especially the which uses the chemical fuels, where the chemical energy is the heat source. So, suppose if you take the Oxy Acetylene welding, so as we know that the heat is transferred by the combustion of the oxy fuel, the fuel which is normally hydrocarbon fuel, that is ignited, and the heat which is released from there, that goes and heats the region where the welding has to take place. So, in those cases your Q, that if you are measuring this in terms of watts, so it will be eta, so that is your efficiency of the heat source, and it will be you have the if you take the acetylene gas as the so heat source, so it will be 48. So if you take this will be 48 kilojoule per liter of per liter of C2H2. So 1 liter for 1 liter C2H2, it's it is liberating 48 kilojoule of energy, and multiplied by volume of C2H2. So what is the volume of C2H2 that you are taking, and then you will have this H upon 3600. So that is your second. So this is hours. So you can have the, if you are measuring in terms of per second, you will have say divided by 3600. So if you look into that, so it comes as 13.3. So this will be 48,000 divided by 3600. So it will be 480 by 36. So it will be 13.3. It's something like 40 by 3. So it will be 13.3. Now 13.3 eta and volume of C2H2. So this way you can calculate. So if you know the volume of C2H2, in that case you can measure the efficiency. So that is your Q. Now this 48 kilojoule, this is the heat of combustion for the C2H2. So the heat of combustion this is 48 kilojoule. So this is per liter. Now what happens by, if you know this volume, how much of C2H2 is used, based on that you can have the and what is the Q. So if you find the Q, that is that will be basically the amount of heat which is required, which has been used to increase the temperature. So once the temperature increase is known to you and property of material then you know that for increasing the temperature up to that extent, what is the amount of Q that has gone into. So and this is the amount 13.3 VC2H2, that is the amount which is generated by the fuel. So in fact by that you can measure the efficiency of the heat source. So it will be varying over a wide range, because it will be so as the fuel consumption will go on increasing, the efficiency will decrease. And the reason is because of the incomplete combustion. So with increasing fuel consumption, the efficiency normally decreases. So the part of the reason is because of incomplete combustion, because you require the amount of oxygen also to have the complete combustion, and if you are increasing, many a times we are increasing for many reasons, and there are certainly different types of flames which are available. Typically you have 3 types of flames. So oxidizing, neutral and carburizing. So if you increase the fuel amount more than what is required for the complete combustion, in that case there will not be complete combustion taking place, and in those cases there will be loss of the fuel, and that will basically decrease the efficiency. So because of incomplete combustion, so that way your efficiency will basically be changing. Then if you talk about these Oxy Acetylene welding processes, here the efficiency will also depend upon other parameters. So, parameters which will be affecting this efficiency. So, for that there are different parameters, like you have torch nozzle diameter, then you have welding speed, you have material thickness, and thermal conductivity of workpiece. So, this way these are the parameters. Basically they will be instrumental in deciding whether the efficiency is high or low, because ultimately you have to think that how you can increase with the same amount of fuel, in what way the temperature of the material can be increased. So, once you increase the temperature, means you are utilizing the energy of the fuel for its use. So, if you typically what has been reported is that the efficiency for these oxy acetylene gas welding process varies from 25 to 80%. So, if you will see there are extreme values. If you may have very less value when you have the wastage of fuels in many situations, or if you have the different type of material properties where it is not able to restore the heat, it is dissipating the heat at a very fast rate. So, certainly the temperature will not go on increasing. So that way, or even the speed also, because if you are going fast, in that case it is not able to increase the temperature in certain localized zone. So, these are the typical parameters which are affecting the thermal efficiency of these processes. So, similarly in other processes also you may have the different working parameters which affects the efficiency of the heat source to certain extent, and that is why you get a range. You get a range that you can, if there is loss, the loss which is there, which that loss becomes more, you will have the efficiency towards the lower side, and if you try to minimize the losses to the surroundings, you can increase the efficiency. Many a times we do certain measures to basically reuse the heat which is liberated to the surroundings. So, there is regenerative you have reuse of those energy which is being dissipated towards the surroundings. So, that way you can increase the efficiency of these processes. So, apart from so if you try to see the different temperature, different properties, the properties which are used basically for these heat sources. Now, when these heat sources are used, some of the material properties we may be in need of knowing, and those material properties which are basically important for us, they are basically the thermal conductivity of the material. So, say suppose K, and depending upon the K it also depends that which type of welding process should we choose, because if the K is very high, and if you are taking a material, if you are taking a process where the heating rate is not so fast, in that case in the time which is available, all the heat will be dissipated towards the through the workpiece. So, for materials like so that challenge is there for materials like aluminum or copper, whose conductivity is quite high. If you look at its conductivity, it will be for aluminum it is 229 kilojoule joule per meter per second per degree C. So, something like similarly for copper it is even higher, it is 384 joule per meter per second per degree C. So, like that you will have while for other materials, like even if you take about the steel, it is something near to 41, then you will have the Inconel, which has even smaller, that is 18 or so. So, for titanium alloy it is 27. Another property which is also coming into picture many a times will be your thermal diffusivity alpha, that is K by rho Cp. So, it will be depending upon K as well as the Cp, and then apart from that, the most important thing is its melting point. So, when we have a higher melting point material, then you have to selectively choose with a typical process, like if you have to melt a material of higher melting point, like if you have to go for a steel, then the Oxy Acetylene welding will not be preferred. So, because you require a large amount of heat, your melting point is higher, for or even for titanium, and other factors also there, like it may be oxidized or so for certain materials. So, depending upon the material properties, like the K or the alpha or the melting point, you take these different heat sources, and also we try to minimize the losses by using the processes in such cases. Thank you very much.